Let's look at equation of a straight line passing through a given point and parallel to a given vector. So now we are actually entering the real three-dimensional geometry. Now we will look at points and try to create equations of lines. We will look at points and lines and try to create equations of plane, right? So in the two-dimensional geometry that you've seen, you've seen these cases. So for example, in your XY plane, if there is a given point, then from that point you can pass a line with a given slope. If basically your slope is tan theta is equal to m, if I say, then the equation of the straight line was something like y is equal to mx plus c, right? You already know this, where your c can be found out when you put the coordinates of this point. So let the coordinates be x1, y1. So you'll put it here, you'll get y1 is equal to mx1 plus c. So your c is y1 minus mx1. So finally your equation of a straight line was y is equal to mx plus y1 minus mx1, where xy represents any general point on this line, right? Xy represents any general point on this line. So any xy which satisfies this particular equation lies on this line. So all these xy's will satisfy this equation. So the way we created the equation of a straight line, the way we write the equation of a straight line is this, where I have a general point xy, right? Similarly here, now what we're trying to do is we have a point A whose position vector is a bar, right? So the position vector of this point is a bar. That means your origin is somewhere here. Let me just redraw this. This is your three-dimensional space. This is your origin, right? So from the origin, you have a vector going in this direction, and this vector is your a bar. You want that straight line which passes through a given point. So it should pass through this point A, and it should be parallel to a given vector. What is your given vector? Your given vector is b bar. So you need this straight line which passes through this point. So the straight line is passing through this point, and it's also it's also parallel to this given vector b bar. So as you can see, this and this, they look parallel to each other. So how do I find the equation of the straight line? So just like your two-dimensional geometry where you had a general point xy, here also I will take a general point on this line. I'll take a general point on this line. Let the position vector of that general point be r bar. The position vector of this general point is r bar. Let this point be p. As you can see, this particular vector, then this vector, and then this vector, they sort of form a triangle. So this vector OA bar plus AP bar plus PO bar should be 0, isn't it? OA bar plus AP bar plus PO bar should be 0. I'm not saying OA bar plus OP bar plus OA bar plus AP bar plus OP bar should be 0. No. This plus reverse like this, it should be 0. So if this is OP bar, as you can see, this is OP bar, then this will be PO bar, right? That's why OA bar plus OP bar plus PO bar equal to 0. This is coming from a triangle law, nothing special. Now, OA bar is basically your A bar. I need AP bar. How do I calculate AP bar? AP bar has some magnitude. I don't know what the magnitude is, but I know that it is in the direction of B bar. Because this AP bar is parallel to this B bar, this particular AP bar it's parallel to B bar, right? So I don't know about its magnitude, but I can obviously write AP bar as some lambda into B bar. My lambda has to be greater than 0, right? So obviously with a suitable lambda, I can get the magnitude as AP bar, but the direction is anyways towards B bar. So this lambda is some scalar. So I'll put lambda into B bar. This is my AP bar. This plus PO bar should be equal to 0. Now I'll take PO bar that side. So finally what you'll get is A bar plus lambda B bar plus PO bar. If you take that side, it will become OP bar. What is your OP bar? OP bar is your R bar. So finally you have got R bar is equals to A bar plus lambda B bar. And this itself is the equation of a straight line which passes This itself is the equation of the straight line which is passing through your given point and is parallel to a given vector. So this is your given point. This is your given parallel vector. So next time when you see a given vector a bar and you have to find the equation of a straight line which passes through this a bar and is parallel to some c bar what you simply do is you write r bar is equals to a bar, write the point's position vector as it is plus some scalar into the direction vector, right? That's how you will get. So as you keep changing lambda, as you keep changing the value of lambda, you will be getting different r bars. For every lambda you'll have a unique r bar, and that's how you'll be able to trace this entire line. So this was the equation of the straight line passing through a given point and parallel to a given vector in the vectorial form. Let's now look at the same line in the symmetric form. This is your vector form. Now we'll try to get the equation in the Cartesian form.